If gravity is supposed to pull things down, does a beam of light really get yanked like a rope, or is something else happening when it curves around a star? In the energy filament theory, light does not get grabbed and bent by an invisible hand. It follows the easiest route through a landscape of tightness in the energy sea, sliding along tension valleys the way water slips into the lowest channel. Textbooks often say gravity bends light, which quietly suggests that some force reaches out across space and tugs on the beam until it curves. Your brain imagines a straight ray being pulled sideways, like a fishing line being jerked by a strong current. In this picture, the starting point is different. The universe is filled everywhere with a stretchy, restless energy sea. Some regions are more tightened than others, meaning the tension in the sea is higher there. If you map that tightness, you don't get a flat floor. You get something more like a landscape of slopes and valleys. Moving from a loose region into a tighter one is like walking downhill into a long, narrow trench. Staying in the tight trenches costs less effort than constantly climbing back out. That is the everyday face of gravity in this view. Everything, from rocks to planets to your body, quietly prefers to move towards and along these tension valleys. Light is special only in that it is extremely good at always choosing the locally easiest path. Earlier we described a bit of light as a very thin, short, twisted filament of motion in the energy sea. A tiny glowing rope being relayed along a narrow corridor. That filament does not know about the whole universe at once. At each tiny step, it only feels the immediate tension around it and looks for the direction that lets the pattern pass forward with the least resistance. In a region where the energy sea is almost equally tight in every direction, the path of least effort forms a straight line. So we got the simple rule: light travels in straight lines. But bringing a massive object into the picture and its tugs on the energy sea itself, cinching it tighter in its neighborhood. The tightness rises as you approach the mass and can form long, deep channels that wrap around it. Now imagine you are walking across a landscape that suddenly grows a gentle but persistent valley next to your route. Each small step, you find that turning slightly toward the valley makes the ground under your feet a little easier. You don't decide to leap sideways all at once. You keep drifting towards the softer line until you find yourself walking inside the valley. From far above, your path looks like it has gracefully curved. That is what light does. At every point along its way, the filament checks the local cost of moving in different directions and quietly nudges towards the one where the energy sea is already pulled tight. The result is a curved track that hugs the tension valley around a star or galaxy. Nothing ever grabs the light and bends it. The road itself is bent, and the light simply refuses to waste effort climbing out of the trench. You can swap the walking picture for another one. Think of building a highway. Engineers almost never laid the road straight over the highest ridges. They wind it through valleys and around hills because that path needs less digging and less fuel for cars. When you drive, you do not feel someone dragging your car into each curve. You just feel the steering naturally following the route that was easiest to build and easiest to drive. In this language, massive bodies are the engineers reshaping the pavement of the energy sea, carving long tension valleys and ridges. Lighting is like a car with perfect steering that always tracks the middle of the smoothest lane. So when we see starlight bending around the sun or galaxies arc background light into rings, we do not have to imagine gravity grabbing photons by the collar. We can say instead that the energy sea around those masses has been pulled into deep, curved valleys. The shortest, cheapest path through that landscape is no longer straight. And light, being the ultimate miser of effort, simply follows that path. The beam curves because the road it trusts has curved. The next question is how this same sea can sometimes let a beam stay as light and sometimes help it grow into particles like electrons. As if a traveling rhythm could condense into a stable loop. Tap follow, share it on New Physics, Clear Universe.